Welcome to all. I decided to give that non-stop questions after one or two more classes because little portion is pending. Now, question 59, master question. I will tell why it is called master question. See, before you start anything, make a note. So far, you should write what all I tell. We consider simply beams, either simply supported beam, that is both are simple supports, or sometimes one hinge, one roller, same today also, or cantilever beams, or beams with overhangs. Sometimes what happens is, in practical field also, see, suppose there is a column, best example, there is a column here. See, this is a beam and column. It is called a frame. Somewhere here, there will be some attachments. See, attachments. Sometimes people call it as what? Attachment is projecting outside, brackets. Or another member is connected here. Some loads are applied here, any type of loading here. Some loads will be there. Now, this load will have an effect on the frame. It will try to push the frame down and try to rotate in the clockwise direction. Now, when you analyze this frame, you need not analyze the full frame, because if you go for some methods there, it will increase the number of unknowns. So what you can do is, you can replace this one, remove it, and in that place, the effect you can transfer. See, I told load acting here, it will give a downward load here, and also a couple, something like this. That is, if any member is attached so rigidly to another member, you can remove that member and transfer the effect on the member you are required to be considered. Now, see, this class I will now furthermore I will discuss in structural analysis, not here. Now, in this class, see, you see here, AB is a beam. A is hinged, B is on roller. It has got a UDL here and 2-point load already given in the question. Now, at the point C, there is an attachment. See, CDE. I written here in the, see, this is given in the question. Remember, this is actually given in the question. Given in question only, that CDE is rigidly connected to the beam AB at the point C. Now, we want support reactions here. There are two ways of calculating it. First, make a note. Suppose you want only support reactions here, then there is no need of replacement or removing that attachment and introducing equivalent force and couple, nothing required. Therefore, I will tell you here now, in the class you write class. See, suppose our interest is only to find support reaction. At where? At A and B. At suppose only reactions at supports are required. Then, see, I will dictate here. I already wrote here. Give it now. See, I already wrote here. Then I will tell in the class. Now, solve the question. You should, what all I tell you should write. Solve as it is. No need of going for replacement, nothing. Consider the full beam, right there. What all I am telling. Consider the entire system. You write here. Entire structural system as it is. There is no need of going for any replacement, nothing required. That is one option. Or how it is given here, same way solve. But later I will tell another approach. I will tell you why it is required once I finish this approach. Okay, I will now finish the approach. So therefore, right, we are solving now, imagining, or suppose, imagining means what? That is, suppose our requirement is only reactions at supports, then consider the, see, this green color numbers, don't see it. They are final answer. I noted down to save the time. Okay, don't see these numbers. No place to write anywhere. So then Consider this frame as it is. How it is given, same way consider. Okay, then. But one thing is important. There are two inclined forces are there. See, inclined loads are there. 120 kN, 70 kN. They should be resolved. Therefore, you start here. Then, see, first resolution. Resolution. Okay, I will do one thing here. See, solution, resolution. Resolution of inclined loads at D and E. See, D going this way, they told 48 degrees, components are here. At E, it is coming this way, components are this way. They told 60 degree with vertical, you consider 30 with horizontal. Components are here. Now, one note. Somebody may ask, sir, you told direct answer without explaining anything. If anybody tells that way, or if anybody cannot find these components, he or she is wasting their time going through my classes. After maybe more than 100, 200 times it came. After so many classes now, if you cannot resolve the components, see, there is no place to write also. See, I have to write cos, sin, all. I don't want to waste space here. So therefore, these two, I will put a question mark here. Okay. Question mark in future, if I write question mark means not wrong, that is, you have to do it. Okay. Correctly do resolution. Okay. Then, before going further, write here, statement. See, in the same, see here, I made everything arranged in a board. You should write the way I am dictating. Then write, let, no, it is partially gone, resolution, remember, let VA upward, HA right side be vertical and horizontal reactions at hinged support at A, and let RB be the reaction normal to plane of roller at B. Since the plane of roller is horizontal, that RB is actually vertical reaction VB. Okay, this all you know it already. So write all the statement. Okay, now after write all the statement, see what is next you have to do now. See, now one more thing important regarding master question. This is a master question because this involves a lot of calculation. I set the question so that you will get complete idea about all this. Later, see, that I feel too much of ink, I think. That's why if ink is more, usually it will spread. Okay, E. Now, what happens is here, see, what I told, too many loads are there. Actually, if you go for competitive examination or practically also, what you will get usually is, see, that's all, or that's all. That's all, simple. So once I finish this master question, next time onwards, this much I will not explain. And one more thing, by going through the master question, you get the complete grip. I will explain each and every concept for this question. Okay, start. Now, I will remove all these unwanted things. This all I told already, space required for me. Okay, this is also over. Resolution I am not removing. Okay, this is all over. Now, draw a neat sketch. Remember, our beam is A to B here. See, A here, B here. Red color will come later. I made it red for some other reason. So, 1 minute. Now, let it be at present black color only. Later, I will make red color. Even this red color is not there. Imagine black color. Okay. Now, see. UDL, first remember UDL from A up to C. 16 kN per meter for 4 meter. Okay, over. Then 40 kilonewton at 2 meter from here. 60 kilonewton at another 2.5 meter. From 10, subtract 4, subtract 2, subtract 2.5, you will get 1.5 meter. Enter. Then at C, vertically it goes up. There is no place right here. See, I'll write here now. This is this level, 3.2 meter. See, given in the question, 3.2 meter. and this load distance is 1.4 meter. Okay. Now, from C, it is going vertically up here. How? By 3.2. Then right side, it goes by 3.6. Then UDL of 10 kN per meter. 125 kN load acting here at 1.4. And anti-clockwise couple of 45 kN meter here. And then this 20 kN load acting this way replaced by these two components. See here, the 25 kN up and left, I entered here. And that 70 kN replaced by down and left. Everything you write. Okay, then solve the question in the usual way. See, there is no place here, space problem is there. I will systematically explain. Okay, start. First step. As usual, sigma m. Today's class is a lengthy class actually. A0, take clockwise positive. Okay. Why moment about A, I will not tell. It is told thousands of times. See, moment about A. Before I go further, last time I will tell. Some will tell, this is already telling 100 times last time. Okay. If the force is, see, moment means load or force. Now load. Load into distance. If the load is vertical, into horizontal distance, or load into perpendicular distance from the point about which you want moment. Now complete system, you want moment about A. So for every load, moment should be about A, except that couple for which there is no distance. See, now when moment about A, when vertical load is there, load into horizontal distance. When horizontal load is there, see here, load, see moment about this point, load into vertical distance. This also told many times earlier. So start. If I take start in order, moment about A, see, minus VB into 10. VB is an unknown force, VB or RB, anything, into 10. That is anti-clockwise. Start. Plus 40 into 2.5 plus 1.5 plus 4 is 8. Plus 40 into 8, y plus clockwise. Plus 60 into 5.5. 5.5. UDL. 16 plus clockwise. 16 kilonewton per meter for 4 meter is the total load. See here. 16 into 4 is the total load. Total load into moment about A into half of 4 by 2. This also over. Continue. 25 is a horizontal load. 25 into this distance. 3.2 subtract 1.4. It is clockwise. Plus 25 into 1.8. If you want, you can write how 1.8 came. 3.2 minus 1.4. How it came? 1.8 over. Then 13.383 into 3.2 anti-clockwise. Minus 13.383 into 3.2, that is anti-clockwise. Then again anti-clockwise, see. Minus 14.863 into, from here, vertical load into 4. This also one. Then see. Then plus. This total load is acting here. See. Here. First write total load plus y plus clockwise. 10 into 3.6 is the total load multiplied by moment about A. See, it is passing here. From here 3.6 by 2. So 4 plus 3.6 by 2. This all I should not explain now. This also over. Then 35 into, again clockwise. 35 into 4 plus 3.6, 7.6. Then 60.622 into 3.2. Into 3.2, that is anti-clockwise. Everything over. Lastly, anti-clockwise 45, so minus 45 equal to 0. You will get the value of VB. Therefore, your VB will come. VB will come in kilonewton. Therefore, you get the value of VB. But 1 minute, I already calculated. I will check the answer. No problem. It will 40 into 8 plus 60 into 5.5 plus 16 into 4 into 2 plus 25 into 1.8 minus 13.383 into 3.2 minus 14.863 into 4, correct, 4, plus 10 into 3.6 into 7.6, correct, not 7.6, into bracket 4 plus 3.6 divided by 2 over minus 60.622 into 3.2 equal to plus 35 into 7.6 minus 45 equal to divided by 10. See, minus VB is there. Take that side. It will come plus, I got the answer, 95.6532. So 100% guaranteed. See, I already got the answer here. Plus 95.6532 kilonewton. I have to check whether the camera is okay or not, because space, I am already going to almost end of the board. Okay, no problem. 6532 kilonewton over. We got VB. Okay, next. Next, make sigma V equal to 0. Take upward positive. This time only vertical load, no distances. Plus VA plus VB. Then minus 16 into 4 is the total load. Only load now, no distance. 16 into 4 is the total load. Minus 60, minus 40. These are not there. Plus 14.863. 863. Minus 10 into 3.6 is the total load. 3.6. Minus 35. Minus 35 equal to 0. Now, substitute for VB. Whatever VB you got, you will get VA in kilonewton. (95.6532) minus 1 plus 16 into 4 plus 100 plus 14.863 minus 1 plus 10 into 3.6 plus 35. 124.4838. 120 plus 124 point, yes, I got same answer, 4838. 4838 kilonewton. Then, lastly, if the space is there, okay, sigma h is 0, I had to verify, okay, most probably space is there. Sigma h 0, take right side positive, safer side. This all I can avoid if I got a laptop covering simultaneously here. That's what I'm going fast, because I will see that I don't have to go there. If a laptop is there, I can see from here only. Then you get plus HA, plus HA, plus 25, plus 25, minus 13.383, minus 60.622 equal to 0. Therefore, you get the value of HA. minus 13.383 minus 60.622 minus 49.005. No, not minus, plus actually. Okay, 49.005. I am not noted because it is easy answer. Nothing there. No chance of mistake. Plus 49.00. Forgot it now. See, 49.005. 005 kilonewton. Okay, right here. Our solution is completely over. Now, lastly, one presentation required. I will do one thing now. Right here. Therefore, somewhere, not there, somewhere here. Therefore, reactions at supports will be as shown below. As shown below. See, what you do is, now this time all loads are all not required. See, I can remove this one. Okay. Show the beam with that attachment. Okay. These loads, this is A, this is B, there is a UDL here. Whatever in the question given, one inclined load here, one inclined load here, then one more load here. Distance is all you write. Everything is not required. The final reaction is, see, we took VB, RB upward, VB, your RB is equal to VB upward, correct, equal to 95.6532 kilonewton. You took VA vertically up, correct, positive came, reaction VA equal to 124.4838 kilonewton. HA, you took right side, positive came, correct, and HA equal to 49.005 kilonewton, right? This is the final answer we got. Neatly enter the answer. Amoeba shape, somewhere outside. Don't have to write everything, loading all not required. Why you want to waste time? If they want resultant reaction, if in case anybody wants resultant reaction, you can find it. Okay. This is the solution when purpose is only to find reaction. Okay, now second round. See, next second round. Second round, same question. Second round, same question, but very, very, very important for SFD and BMD. I will explain what is that one. So therefore, first round is over now. Second round, we will do the question. Wait, I rub and prepare for it. Now, second round, remember, most important. First class, don't see there, first class. Write everything I explain and dictate. It is your responsibility. What all I tell, each and everything you have to write and make a note. Okay, start. I will tell here. First write. Suppose our purpose is not, see, I dictate, not only just finding reactions, but also to draw SFD and BMD, be careful, for the beam AB, that's all, for only beam AB. For beam AB, our main beam is AB, or deflection calculation, or practically design purpose. In that case, You need not consider the end. See, all I am dictating. You need not consider the entire system and write it and find the reactions we found like last time. What you can do is consider only AB. Consider only AB, red color. Only AB. See, red color beam, AB. With whatever, you should write, with whatever loading given on AB, that is, see, 16 kN per meter for 4 meter, 40 kN and 60 kN, that's all. And the attachment, that is C point, see, I forgot it, C. Now C become red point now, very important point. And the attachment CDE, actually, due to some reason, I will write the sketch once again. CDE, okay. There's an anti-clockwise couple here, I forgot here, 45 kilonewton meter, okay. And the attachment CDE is removed. See, you cut it and throw it outside. But do one thing, when you throw it outside, whatever is the effect of that loading on CDE should be transferred to beam AB at the contact point. See, this all you are right. CDE is rigidly connected to beam AB at C. So whatever loading is there on that attachment part, CDE, I will call attachment or bracket, whatever is there, they are replaced by equivalent load and couple at C. Or what this CDE will transfer to beam AB. Remember, it is transferring action, not reaction. It is action. Because of all this, what will happen to beam AB? You write all this, you write here. Then, see, I wrote fair copy. Consider, now solution starts. Solution. Okay. Now solution, 1 minute. Solution, but first resolution. First resolution, okay. Resolution is already over here, see, already over. Write once again for understanding purpose, write once again. Don't think already over, already not over. You are doing fresh calculation. Resolution. Consider CDE, see, CDE rigidly connected to beam AB at C. See here, CD, we have to find loads, horizontal and vertical both, but sometimes we only one of them, and a couple transferred to beam AB at C, where CD is rigidly connected to beam AB. Where this attachment is connected to C, this complete, you remove it, and at the contact point, transfer whatever load comes and whatever couple comes. And then consider only beam AB, see, this way, only AB along with the load, with the given loading on AB, see, this UDL, this point load, it may be there or may not be there. So many times they don't give it. With the loading on AB, along with, see, green color, along with loads and couple transferred to AB at C, where attachment is rigidly connected to C, that is, we will consider this beam. I am rubbing out everything now. So later, I may forget it. I made a note here, 40 at 2 meter from there, 60 at 2.5 further, UDL is 16 kN per meter, 4 meter. Okay, span I remember. I made a note somewhere there. Do not bother this answer. Don't see this one. That we will write. Now, see, our sketch will be, see here, our consider only, see, now consider only AB. Maybe, see, A is here, see, A is here. This is B, roller support, B. This loading not required now, see. Our purpose is only CDE connected here. So, 3.2 meter height, where is the space? No space here, I will write here. I will write one more sketch anyway. 3.2 meter height, then 25 kN at 1.4 meter from top. This 20 kN load, inclined load, we already resolved here, enter resolved components. UDL of 10 kN per meter for 3.6 meter. Then here, anti-clockwise couple of 45 and 70 kN load resolved here components. This is what you are considering. Over. Now I will do one thing. Full board I am removing. This sketch very neatly I am writing here. Now original beam you cannot see now. See, I explained so much actually. Now you cannot see the original beam. Okay. I will write neatly. Okay, now I wrote completely here. This again, it was there, it was disturbing me. I transferred the answer here. Don't see this one now. Okay, this is arrangement now. See, I wrote everything once again in the sketch. Now, very clearly understand the principle. Once you understand the principle, there is nothing there. See, 1 minute. Okay. See, first, consider, you make a note. Each and every force separately, consider it, each force and couple separately. Consider it first at the original position, that is in the attachment CDE, where it is acting. Transfer it to C. See, this transfer theory, I already told long back. Replacement of a force by force and couple. See, if a force of downward is acting, if you transfer here, the downward load will come downward here with a couple. If it is upward, it will give anti-clockwise couple. Same way, you start one by one. See, correct order, consider, see, 25 kilonewton at F. I will do one thing. When I write the transfer defect, I will use green color. Consider 25 kilonewton, this load, okay. 25 kN, I am considering 25 kN at F. See here. C is here. F is here. 1.8 meter, 25. Put the finger at C. See now. If you put the finger at C, this 25 will push the beam right side. See, this 25 kN will push right side by 25, but it will also produce a couple of 25 into 1.8 clockwise, 45 kilonewton meter. This is the effect of 25 kN at F to the beam AB at C. Okay, over. Consider 13.383 kilonewton at D, which is left side force. See here, I wrote 13.383 at D, 3.2 meter. It will push the beam to left side, see, left side by 13.383 and will produce a couple of 13.383 into 3.2 anti-clockwise. See there. Over. Then consider UDL, consider 14.863 kilonewton at D. Okay, it is vertically up. So this force load will lift the point C in the upward direction by 14.863 and there will be no couple because force is passing through C. No, see, it will not rotate. See, this will push and rotate. It will push and rotate. This will only lift it. Okay, over. Consider UDL of D to E. See here. See now. First, this has got a total load here, acting here. So this full load will press the point C down by 10 kN per meter for 3.6 meter total load, 36 kilonewton, and will produce a couple of the load 10 into 3.6 is the load, moment about C into half of 3.6, 64.8 clockwise. Consider 35 kilonewton at E. This is very simple. Down 35 and clockwise of 35 into 3.6, 126. Consider 60.622 at E, this way. See here. If you come here, it will push the beam left side by 60.62 left side and will produce anti-clockwise couple of 60.622 into 3.2 equal to into 3.2, 193.9904 kilonewton meter. Lastly, consider the couple of 45 at E. You know, when a couple is acting here, when you transfer here, there is no load. Wherever you apply the couple, effect is same. It will produce an anti-clockwise couple of 45 at C. This all correctly understand. Then, next step. Therefore, see here. Therefore, vertical load transferred to B. You can write if you want. Net, you can write net. Everywhere, add one net word, net. Or here also, one net. Result, net or resultant. You can write net vertical load transferred to AB at C is, see here. Now do one thing. Do not see left side now. See. Now see this one. See only, effect only you have to see. This one, this one, this one, this one, this one, this one, and this one is, see here. We are calculating vertical load. No, these are horizontal. 14.863 up. Then 36 down. See, some people will tell, sir, that is upward, sir. You put plus. No, this is not plus minus sign convention. It is called a vector. When you write something with the vector sign, you should always write plus. See, for example, see, suppose you have 10 down and 16 up. You should write 10 down plus 16 up. But answer is 10 down, 16 up is 6 up, that way. This plus is what? This plus means adding the effect. It is not clockwise, it is not downward upward sign convention. That is called summation. When you write the arrow mark here, vector mark, then no minus sign. See, or common sense. See, 14.863, where is it? 14.863 in the upward direction, 36 in the downward direction, one more here, 35 in the downward direction. That's all. Now do one thing, equal to, see, if you want, you can write one more statement there, see, or equal to, see here, what I am doing. 14 point, if you want, you can write 14.863 is in upward direction plus 36 down and 35 down are 36 down and 35 down are 71 down. 71 down, 14.863 up means higher one. From 71, you subtract 14.863, net is 56.137 down. This is the final answer at C. Now, net horizontal load at A, at C. Here. 25 right, I wrote there. 25 right, 13.383 left, then not there. 60.622 left. Or if you want, you can write equal to, see here, 25 right and then 13.383 left and also 60.622 left. Both together plus 74.005 left. Now, right side 25, left side 74.005 means from 74.005 subtract 25. 49.005 to left side. No plus minus now. Over. And lastly, very important, net couple transport at C is, first you write, see here, 45 clockwise, 42.8256 anti-clockwise, 64.8 clockwise, 126 clockwise, 193.9904 anti-clockwise, and 45 anti-clockwise. Now you can do one thing. If you got difficulty for calculating net value, see what to do. I will remove this one now. This is not required now. See, this is not required. You can do one thing. Once you write this much, then you write equal to, see here, equal to. First consider all the clockwise. 45 clockwise, then plus 64.8 clockwise and 126 clockwise. All three clockwise together is, it is equal to, okay, I'll use red color, 235.8, that much clockwise, and see, 42.8256 anti-clockwise and 193.9904 anti-clockwise, and also 45 anti-clockwise is 281.816 anti-clockwise, or you can write finally answer or equal to, see here, I think space problem is not there, okay, equal to net one single answer. How much it is? Anti-clockwise is more, 281.816 minus sub 235.8, 46.016 kilonewton meter anti-clockwise is the final answer. Final, 1 minute now, let's check the camera. Okay, no problem. Final answer, over. This is the net effect. Now, one important concept. Why I am doing part by part reason is there, because usually, I will now do one thing now, this all I will remove. Why I am doing part by part, I will explain. Suppose a question given, see here, a question given, 10 kn at 2 meter. If you want equal to, see here, 10 down, 10 into 2, 20 clockwise, over. Therefore, part by part is very useful when you go for simple question. But this question, you can do one thing. You can make a note. Instead of all these, see here, instead of all these, when too many transfers are there, when transfer is too much more, right there, if see here heavy number is there, correct? 46.016, correct. Okay. Or you can do one thing, directly, see, directly, right here, directly, no need of cuts, part by part, single step you can do, that is here, I write here, or directly refer the sketch, right here. Net vertical load transferred to beam AB, our beam is AB, beam AB at which point? Very, very important, at C equal to, see here, directly, see here. Now you require sign convention. We will do one thing. We will take upward positive, okay. Upward positive, anything positive. Upward positive, actually it's surely downward positive, okay. Is, see here, directly find the net force, plus 40, see, put the finger at C, then see, plus 14.863, minus 10 into 3.6. This is upward, this is downward, minus 35. Equal to, calculate now. Actually not required to calculate, answer is there. 14.863 minus 10 into 3.6 minus 35. 56.137 equal to minus 56.137 kilonewton. That means it is 56.137 kilonewton. We took upward positive, negative came that much, downward is the net force transferred. So see here, correct. Then same way, net horizontal load transferred to our main beam AB, to our beam AB at C equal to sign required. We will take right side positive. Okay. Right side positive equal to plus 25. See here. Plus 25 minus 13.383. 383. Then vertical, see, minus 60.622. Calculate. Plus 25 minus 13.383 minus 60.622 is minus 49.005. Minus 49.005 kilonewton. That means it is net load is 49.005 kilonewton to not, we took right side positive, left side negative came to left side. No minus sign now. And net couple transferred to your beam AB. See how much I am taking effort here. AB at C. We will do one thing. We will take usual clockwise positive equal to, see here. Take moment about C. 25 into this distance is from 3.2 subtract 1.4, already told 1.8 clockwise, plus 25 into 1.8, see, 13.383 into 3.3 is anti-clockwise, minus 13.383 into 3.2, then this has no moment. Okay, right here if you want, plus 14.863 into 0, 10 into 3.6 is the total load into 3.6 by 2, already explained for you, the total load into this distance clockwise, so plus 35 into 3.6 minus 60.622 into 3.2, lastly minus 45, no into, only couple, minus 45 equal to calculate. Okay, I'll check the answer. 25 into 1.8 minus 13.383 into 3.2 plus 10 into 3.6 into 3.6 divided by 2 plus 35 into 3.6 minus 60.622 into 3.2 minus 45. 46 minus 46 point, everything came minus, good, not 16 kilonewton meter. That means the net couple is 46.016 kilonewton meter in the anti-clockwise direction, because negative came over. And now both are same answer. See, you can see here, I noted the answer here. Okay. Now, last step, I will do one thing now. For last step, I will remove everything and write it somewhere here. 1 minute. Now, class, I will tell, write a note. Actually, I already told. Now consider only the beam AB. What span? How much? 10 meter span. See, whatever loading given on the beam AB right here, 4 meter, 16 kN per meter. These two loads I already told earlier. 40 at 2 meter, 60 at further 2.5, gap will become 1.5 meter. With only loading, already given loading on the beam AB, if it is there. And also, very important, and also the loads and couples transferred, you should write transferred to beam AB at the point C where that attachment is rigidly connected. We know the answer. See, green color. What is the green color? Net vertical load of 56.137 kilonewton net horizontal load of 49.005 at C and a net couple of 46.016 kilonewton meter. Okay, now usual. This I should not write. Let VA and HA be vertical horizontal reaction at A, immediate support, RB reaction, already known VB, this all over, start. Now usual, sigma m about A equal to 0, YA I will not tell, clockwise positive, start. Minus VB into 10, minus VB into 10, then plus 40 into 8, 8 plus 60 into 5.5, 60 into 5.5 over plus 56.137 into 4 plus 56.137 into 4. This is the transferred load. See, transferred load. Plus 16 into 4 is the total load. Total load into 4 by 2 into 4 by 2 and then minus 46.016 minus 46.016 equal to 0 because this horizontal force has no moment about A. You will get the value of VB. Therefore, VB will come. Where I noted the answer? I rubbed it. Oh, okay. I remember the answer still. VB will come in kilonewton, 95 point something. If it is not coming, I will completely close my class. 95 point something. I forgot it. Okay, okay. See, I rubbed it out. Who will check once again now? 40 into 8 plus 60 into 5.5 plus 56.137 into 4 plus 16 into 4 into 2 minus 46.016 equal to divided by 10. 95.6532 kilonewton. 95 point plus 95.6532 kilonewton is the reaction VB. Sigma V0, take upward positive, plus VA plus VB minus 16 into 4 is the UDL minus that transferred load. How much it is? 56.137, the transferred load. Then minus 60 minus 40 equal to 0. Substitute for VB, whatever you got. Substitute for VB, whatever you got. Therefore, you get the value of VA in kilonewton. 124 something I remember. Okay, no problem. Minus 1 plus 16 into 4 plus 56.132, 137 plus 100 plus 124.4838 kilonewton. 4838 kilonewton. Sigma H equal to 0. Take right side positive plus HA minus the transferred load minus 49.005 equal to 0 over, therefore your HA equal to, plus 49.005 kilonewton. Okay, now, right, therefore, now this all you remove it here. Okay, right here, write the beam once again and write here RB equal to V, not here. Write once again there because I will tell you why. It is 95.6532 kilonewton. VA all positive, so no change of direction. 124.4838 kilonewton. HA equal to 49 point, no change of sign direction because all positive kilonewton. Remember, make a note here. Now, this beam for this later, you can draw SFD and BMD. Not now. See, you can draw SFD and BMD. See, SFD will come. BMD. That all you bother later. For this, later you can draw SFD BMD. Our purpose is over. So understand both the concept. Next time onwards, next class, I will solve some 4-5 questions. Very simple. You will enjoy it. This is a master question, so that concept is completely clear for you. Go through repeatedly each and everything I told, you write it and understand. Okay, thank you. Next time we'll continue.